Teşekkür ederim. Katılım.
Thank you for being here. My name is Emre YIGITOGLU from TURK company. I work for the R&D department. Today I will talk about carbon fiber. Reinforced plastic for lower control arms. What do we do in our company within Coşkunes? I would like to explain you this. Then use of composite material in automotive sector, legal requirements, and OEM cooperations with composite producers, and a summary about what we have been doing. Within Coşkunes, we use AutoCAD software, SolidWorks, and CATIA softwares. We use computer-assisted design. We do the computer-assisted analysis. We have virtual tests and genuine tests, physical tests. We verify them and then we collect data, and reverse engineering is done, prototyping, optimization, and benchmarking. These are the work steps we have in R&D. Which materials do we use? Especially in R&D department, we use metal and composite materials. For metals, we use double phase steel or complex phase steels. We use tweed steel, QP third generation steels, and we use composite materials. We work on composites. Magnesium and aluminum are the areas we work on. Well, with the new materials, there are innovations in the automotive sector because of different needs and new needs. We have different innovations as well. Why do we use composite materials? Because there are limitations on CO2 emissions, and the ban will be there as of 2020. The fines will be valid as of 2020. It's very important that composite materials decrease fuel consumption, and it is expected to have high endurance. Well, it has to be light, but at the same time it has to increase the reinforcement and endurance. So it has to be endurant in case there is any crash. European, in 2012, the data was explained and CO2 was 130 was the limit. But as of 2015, there has been no bans, but it was started to be used this year. But in 2020, it's expected to be 95%, and in 2025 it has to be 80 grams per kilometer. Well, there are different targets, and every year 7 grams per kilometer decrease in weight is expected. Oh, sorry, 7 gram per kilogram decrease in CO2 emissions are expected. How can we do this? We can do this by decreasing the weight. The electricity cars, there is 12 kilometers increase. BMW i3 has been produced, and the oil will be 180 kilometers, and plus 12 kilometers, that is going to be like 10%. It's a huge number. Till 2020, it's going to be 250 kilograms, and in 2025, with only material decrease of weight, you need to decrease the weight by 40 420 kilograms. Moreover, the drive distance is expected to increase by 65%. If these are not applied, when we are in 2020, €5 will be fined to the automotive producers for 1 gram per kilometer exceeding. If it is 2 grams, it's €15. If it is 3 grams, it's excess. I mean, it's going to be 25. If it is more than 3 grams, for every gram, it's going to be €95. So the automotive industry cannot bear this. So other than aerodynamic, they have to work on weight as well, and composite material is a must here. Composite material is challenging for serial production. They want to have serial production because an automotive producer produces a part based on seconds. When we look at the composites, that might last minutes, hours, and sometimes days, especially in aviation sector. Here, one other impact is that the high costs the aviation industry bears cannot be tolerated in the automotive industry. When it's serial production, of course, the cost of production will go down. While this is I3, this is available in the market. In the first 6 months, the expectations were very high, but in 6 months, only 50,000 sales have been realized globally. 55,000 sales annually in 6 months. The body is very light, can be raised by 2 people, and it's a body that is produced at a single step, but then adhered. Parts are adhered to each other. Where can we use composites? On seats. Seat producers can use composites, and chassis could benefit from composites. This is one of the most important places because the composite material used here has to be endurant. It's not like the body. On the external body, composite material can be produced easily, but when it's the chassis, you have to fill in the expectations, satisfy the expectations. And on the door, well, against the impacts coming from the side, we have to have the side door bar, and the tires also can benefit from composite materials. What is being produced currently? The lower arm of Lamborghini car is a productive lower control arm. It is used with SMC method. There is the side door bar. It's produced by DuPont, and it's a thermoplastic based side door bar. It is used to absorb the impact, and there is the control arm at the upper side. You can see it's a thermoplastic control arm. It's produced yet, but the tests are still going on. What do the OEMs do to cope with the innovation? BMW and SGL Group cooperate. Mercedes cooperate with Toray, Ford cooperate with Dove, Renault with Caterham Cars, and GM cooperates with Teijin Group. And they try to keep the things together. Coşkun Öz, what do we do as Coşkun Öz? For R&D, we have a composite press we use for R&D purposes, I mean. And one of the first works we did is the side door bar. Thermostat base was used, resin and fabric combination, and prep rack was also used for production. Here you can see the production steps, some of the production steps. We use the heating in mold method. We manually tilt the material in the mold, and under certain pressure we cure it under high temperature, and we produce the material, the part. And in order to compare them, together with the steel materials, together with the side door bars, we make comparisons, and there's a certain displacement, 50 millimeters, 100 millimeters displacements are applied, and we are comparing the energy that is absorbed over here. The control arm material, thermoset, is used here. Fabric, fiber, and resin is used here. Thermoplastic control arm, first studies, first works, and then the thermoset was produced. It's a composite control arm. Well, before we started studying on this, we worked on thermoplastic, because thermoplastic is an important material. It's used heavily in automotive sector, but the load cannot be ensured. We need higher strength materials. We produce this material in cooperation with our partners. And then how do we prepare the process? Prepreg materials are cut at first at certain measurements. We prepare them. After we put them on top of each other, we put it in the mold, we form it in the mold. After the preforming, we put it in the mold again, and we use the metal parts to cure it. After the curing, because it's thermoset material, it has roughness on the edges, and we cut the edges. And after it's cut, this is the final product. Well, as a thermoset, we produce this composite control arm. With Sujiti, we cut the edges, we cut the piece, and we had the aluminum 5000 series on the metal sides. We combined them, assembled them, and you can see it in the hall, by the way, on our stand. We sent it to cut-off-res, and we had a similar view. And here we used the rubber materials to test. Together with the innovative approach we had, we put aluminum material in between. This is the material. There is a porous material. Well, aluminum material was produced as a porous material, and we prepared the surface of the aluminum material. Thermoset prepreg materials and the aluminum with the prepared surface were adhered on top of each other, and they were cured afterwards. The product was produced. The product is now seeking patent, and we are expecting the result. Thank you for your attention. If you have any questions, I will be happy to help.